It says write the standard, mathematics, 9 through 12, functions 2.1. Identify the effect of the graph after replacing f of x with f of x plus k, which yesterday we just got into it on the handout. If you put a plus or minus after that function notation, that will shift the graph up or down. That's what we were practicing yesterday. And f parentheses x plus k. You know what? Who's written this down already? Let's do thumbs up if you've already written the whole standard. I'm going to change one thing, you guys. I want this to say f x plus h. I want to change that to an h in there. So the difference, Riley, face forward, please. The difference between the first and the second is the parentheses. I'll get you one. Is that eight wrong? Is the right over right? It's right. Okay. So there is a big difference between adding a number after the symbol f of x and adding a number within parentheses. After will shift the graph up and down. Inside the parentheses will shift it left and right. So there is a difference between these two things in this formal definition. So we're going to graph for number 2, y equals x. Students trophy, there's not enough numbers. And then we're going to graph y equals 3x on the same coordinate plane. And we're going to observe the differences between the two. So we have to make two perfectly straight lines. Starting with this line y equals x. Riley, when you face forward, you will see an equation y equals x. There's no visible numbers in this equation, but there are some invisible numbers. You can't see them, they're invisible. What's the slope here? If I'm thinking about, let me just relabel from yesterday, y equals mx plus b, and I'll remind y'all that a number in front of x is a slope, also known as a rate of change, also known as rise over run. And the number at the end, which is a constant, is the y-intercept, also known as an initial value, like the shoe rental in the bowling problem yesterday. Okay? So I got a problem here with this equation y equals x. Abby, what's the slope? There's no number. What number is right here? I would say there's typically two things people say. They either say 1 or 0. This is an invisible 1. There is an invisible 1 here. As a math teacher, I get highly annoyed that 1s are invisible because I know y'all can't see them, and it's more difficult for you. I say, let's just write it in. Why do we have to make it invisible? But there it is, this 1. So what's the slope of 1? Up 1 over 1, up 1 over 1. The rise over run is 1, 1. Actually, no. Thank you for saying Look at that. Another invisible number. If there is no B value, there is a zero sitting there that is not written. Invisible zero. You saw it, Ari? You see the invisible numbers now? So what's the invisible B value? Yeah, so this is actually 1x plus 0. But it's more difficult because the numbers aren't written. Karma, did you graph y equals x yet? Where did you begin your graph on the y-axis? So I'm actually going to begin at 0. Because it's mx plus b, you begin at b. Beginning at 0, you're going to move up 1, right 1. Begin at 0. I hear some side conversations. Please stop them. So here I go 0, up 1 over 1, up 1 over 1. They call this the parent most basic function because there's no numbers in it. Y equals x goes right through the origin, has a slope of up 1 over 1. This is called the most basic line. It's so basic. There's nothing interesting about it. There's no minus signs, there's no coefficients, there's no constants. Y equals x right from the middle, up 1 over 1. It's the most boring slope. Okay? Y equals x. Students forget how to graph it all the time because they can't see numbers, but it's actually the easiest line there is to graph. 0, up 1 over 1, up 1 over 1. Next one. It's so basic. You know why I overemphasize this? Is because I see students year after year not know how to do it. Algebra 2 students who can graph y equals 3x just fine, totally blank out on y equals x because they can't see the slope number and they can't see the b number. So people get stopped on it. All right, next.
Yes.
You guys, let's focus on the math content and not get involved in the bathroom line. Nevaeh. For y equals 3x, where should I begin my graph? What is the b value? 0. So this has a 0 in it as well. If there isn't a number second, you always begin at the origin. And what will the rise over run be in this one? Up 3 over 1. Don't pull in this number and this number. They're two different things. This is the slope. Up 3, right 1. Here we go. Starting at 0, up 3, right 1. I want to follow that same pattern down and connect it. Devin, how'd you do? You done? So what have you done? That's all we've done is graph. Oh, you wrote the standard. Okay, good. So I've now reviewed with you guys. The slope is the number in front of x, representing the rise over run. The constant at the end is the y-intercept, and that's where you begin. If there is no number there, you begin at 0. and then do rise over run. Okay? Number 3 is really the most important one. It's going to show the most growth as far as your learning goes. Describe the transformation shown in the graph. So if we were to call this red one y equals x, the original, and y equals 3x is the new one, how would you describe the difference between the blue one and the red one? I figure you know. I think you might know. Can you just, if someone, let's say you weren't even in that class, we never did anything. Could you just describe for me how the blue one's different than the red one? Do you know something? It's what? It is different points. It is different points. It is steeper. Steeper is the answer we're looking for. Okay. So I'm going to go ahead and say that y equals 3x is more steep than y equals x. Okay? And why is it more steep? It's more steep because the slope is up 3 over 1 instead of up 1 over 1. Yesterday on the handout, I told you something more steep is called a vertical stretch. So I'm going to write this out for number 3. It is a vertical stretch of 3. If someone were to start with the red line as if it was a rubber band and kind of put force on it and pull it upward, it would become more steep. And that's why it's called a vertical stretch of 3. Riley. What can't you see? This? Did you hear anything I was saying? My goodness. You guys? Did you guys have anything else to ask? Did you hear me? Okay. Yeah, that's why it's shown visually and explained auditorily. So, okay. I'm glad we're on the same page. When you're done, hopefully you understand what I mean by more steep. Please get out the handout from yesterday. We're going to look at some more of these.
I need the handout. What?
Who else needs your handout from yesterday? Alright. If you were not here yesterday, there is a video posted that shows kind of the first half of this. Or you can just look at somebody else's. Like if you want to take a phone out for 1 second and maybe take a picture of one of these, here you can. Actually, let me just put it up from yesterday. This is the handout from yesterday, y'all. Here, sorry. If you were not here yesterday and you want to pull a phone out for 1 second and take a picture of this screen and then put it right away, you can do that tomorrow. How do you know?
Take a picture.
Bro, okay, I'm not taking a picture.
You are not close. You cannot do that.
I'll send it to you.
Please put your phones away. Everyone put your phones away. Everyone put your phones away. Alright, now there is also a video posted with this. Okay? Alright, in Schoology. In Schoology, it's called Quarter 2, Week 2. Everything that we've done is in there. Alright, let's go down to skill number 2. That's where we're picking up right now. Y'all be quiet. Y'all be quiet. Let's go back to raising hands here. Everyone's talking a little bit too much. Jaden, you have a question. Yes. You're welcome. Riley. That's there. I'll put it here while I get Caden a pencil. There it is. Alright, now I'm moving on. So you guys, Bradley, you have to finish that later.
I got it.
Okay. So a horizontal translation is shown by a number written inside the parentheses. Inside parentheses after X. This will shift a graph left or right, always opposite. This word is translation. Translation. Please don't play. Focus on your work. You don't need a computer right now. We're just doing this handout. Alright, so everybody right now, without even looking at my screen, okay? I don't want you guys looking at my screen trying to copy how to graph a line at this point. Look at your handout and graph 3x plus 4. Okay, at this point, you should be able to graph this line right now on your own. I will graph it and explain it, but you should not be trying to copy me graph this line. You should be trying to do it yourself. Just look at your paper. Do you know how to graph 3x plus 4? Did you just clap at me? Don't do that. Shh. Do you know where to start on the y-axis? Do you start at the 3 or the 4? You start at the 4. On the up or down? It's B for begin and M for move. When you begin on the y-axis. So you shouldn't be trying to copy my points up here. You should know how to start at 4 looking at your own paper. Start at 4. What is your question? Yeah. I think I do have an extra one. Number 4. Alright, so I begin at 4, and then I'm going to count up 3 over 1. Up 3 over 1. I love your question. Why over 1? Now 3 doesn't have a denominator. When something doesn't have a denominator, there is an invisible 1 below it. So when I see 3x plus 4, and I know my intention for slope is to do rise over run, I see that I go up 3 Yes. Yes. And I want you to, this is not it. I don't want to see a line only on half the page. I want you to extend the pattern the other way. So that would be down 3 and left 1. So make a straight line pattern all the way across this graph. Now, when you have function notation, fancy function notation, and there's a number within parentheses, this means take your existing line and shift it either left or right. Now, I would think this was left 5, but it's interesting. It's always opposite of how it looks. So this right here means I'm going to take my graph and I'm going to move every point right 5. Every point gets moved right 5. When there's a number in parentheses, it's left and right, opposite of what you might think. Alright, 5 units. So I'm going to just pick a point on my paper. Don't try to copy it up here. That's too hard. Pick a point on your paper and count to the right 5. Any one of these points, you count right 5 and make a dot. It is pretty tiny. Yeah. Same handout from yesterday. Yeah, if you just want to move 1, and then you can do the slope pattern because it's parallel. It's the same slope. So like the first one that I did, the original, I'm gonna label it f of x. The new one that I did is called h of x, and that tells people what they're looking at. So f is the original, h is the x function shifted right 5. So I'm gonna label this blue one h of x. If you guys have a highlighter and you want to keep the original f function in a pencil, and then for the second one, if you want to like highlight it to show that it's the new one, the shift, you can. Sometimes that's nice. Or a pen. Just do it in pencil first in case you mess up and have to erase. Alright, now everybody move on to number 5. Just try to graph the first equation on your own correctly. Where do you begin and how do you move?
I thought it was home before. Y'all be playing dress going first? Me too, girl. Skin is the queso avatar. The big one. And I be using a fake face on it. Ban 'em. Have y'all seen the average queso meal? Who's there right now? James. He got here. He got here last. I think he put his name third. I put his name so he just has his name is third. Average. I didn't put his name. I don't care. It's gonna stay like that. For sure. Like that. I put her name down too. And sometimes I put hers. Put his fourth. Put his fourth. Average case meal. See, bruh? Average case meal.
Okay, I see you guys are ahead of me. That's so great. You guys are ready for H. So this is the F function starting at -1 and going up 2 over 1. Now I'm going to graph another one called H. And H is the F function moved left 6. That's okay. Hopefully you did it in pencil. So this means whatever you're at, take every point and count to the left 6.
You got a highlighter?
Yes, that's your music.
You got a highlighter? You got another one?
Hey,
That's Asa. Yeah, that's Asa.
Alright, y'all are quiet. Here's something in here. What do I hear? Turn that off. So guys, I just really want to define this skill really quick. There's 2 things we're working on. The first thing is just being able to graph the first F function by yourself, right? And the second one is understanding that sometimes we start with a line and then we just move it. We just practice moving it. We shift it around left and right, up and down. Our visual games, our programs, and our computers, they are using these symbols in their programming language. They take existing images, and when they move them, it says plus or minus to move right and left. Has anyone ever done Scratch before, the coding program? Yep. It's very similar to what we're doing right here. All right, I'm ready for number 6. And it definitely looks a little more challenging than the other 2. This has a +0 next to it. So for this one, we begin at 0. And then the move here is actually going to be down 5 and right 4. So I'm wondering if you guys can create a negative slope now. You go down and right, down and right. Was that your question, David? Starting at 0, down 5, right 4.
I can do it. I saw you doing the left hand.
Yes, I criterion of
Let's do it. Let's do it. Take it slow. I don't want to go too quick.
I was being distracted. Oh my
Let's
god.
do it.
Should I do this
Okay.
one?
I was
Come
going
on.
on the wrong grab.
Look, I'm ahead of you. Let's go. This isn't time to chat.
Oh, no. Oh, yeah, straight line, totally.
Yes, that is correct, but only in parentheses. Yesterday we did not mention opposites. So if it's after the parentheses, you do it exactly like ellipse. If it's in the parentheses, it's opposite. If it's not, like this plus 8 was up 8. Yes. 1, 2. How about are you working on it right this second? What if I finish 6 and then you take another picture?
This is not gonna be straight. Because mine kind of missed like 3 dots. But like I'm pretty sure I placed it right.
Yeah, that's a good reason to use pencil. Okay. I already heard someone in the back. They know what to do. They know how H is going to be. What does this plus 3 do to the graph of F? Left 3. Good. And if you're saying back this way, you're right. Left 3, back 3. So H is F of X moved left 3 units. So every point I'm counting left 3. I think that was 2. Who made this? It's too little.
It's hard to copy.
Alright, you want just the bottom 3 or all of it? Bottom 3. If you want to take a picture, go ahead, but you're coming immediately away.
You need your pencil back.
What about the back?
Oh, where's the bag?
I see someone wrote it on
Yes.
Y'all be quiet. Y'all be quiet. Listen. This handout has a lot. It's covering 4 things. It's covering shifts up and down. That was yesterday. It's covering shifts left and right. That's what we just did. It's going to cover reflections, which is flips. And it's also covering making things steeper and flatter. So flip to the back. Let's do another thing.
I just want to finish this. No, she won't. 219. 211. I'm sorry for you.
All right, guys, listen. We are now going to practice a reflection. This time it's a reflection across the x-axis. In Algebra 2, we'll talk about reflecting across the y-axis and the x-axis. So, understanding reflections in function notation. A negative sign in front of f of x will flip a graph across an x-axis. So, once again, graph the first one on your own. We've already graphed this exact line. 3x plus 4. You should know where to begin and which to do rise over run. So start with the original f of x, and then I will show you how to reflect it. It's a good argument for going silent. You guys are close to more. Videos in Khan Academy. Check in with silence again. It feels a little more clear on the back. I think these ones are bigger. And then 3 over 1. Alright, everybody has had time to graph f of x. So how do I do this? What do I do with this negative sign? How do I reflect it?
You make it go the other.
You can try counting and actually flipping across the x-axis. So some people visually they can do that. They can take this one and you're pretending to fold the paper in half. Where would the points end up if you folded it? I like to know more precisely how to do it. So this is like -1 times f of x. So I'm going to actually just distribute -1 into the expression. So it's -1 times 3x plus 4. I'm going to do -1 times the 3 and -1 times the 4. So the new function is going to be y equals -3x minus 4. And we're actually going to call it g instead of f. So pretty much I just multiplied by -1. And that's -3x minus 4. So for my second line, I'm going to start at -4. And I'm going to go down 3 over 1. Down 3 over 1. The bottom 4. So this is where I begin. Down here. The slope of this new line is -3 over 1. So down 3, right 1. Down 3, right 1.
Now nobody cares.
There's the reflection.
Yeah, -2. Whatever.
What's what line called?
Yeah, like on the other side, we had FX.
This one says it's called G. F of X. G of X. Y'all got like 8 minutes. You can do it. 8 more minutes.
No, I can't do it. Yeah.
All right, hey, I'm gonna go ahead to number 8, or maybe I should do. I'm actually gonna skip down to do number 10. Okay, skill number 4. Understand. This time we're gonna understand the stretch or the shrink in function notation. Kata, stop talking, please. Nathan, you remember in Bellwork we already have done a stretch. Up 1 over 1 was the regular, up 3 over 1 is the stretch. That's what we're doing here. But this time I'm going to begin with f of x, and this is going to be a vertical stretch of 4. -2, and I'm going up 1 over 1, up 1 over 1. This is the most advanced one down here in the bottom, or the back. This stretches and shrinks. It's even difficult for algebra 2 students. We stretch and shrink every function in algebra 2. We do it like one week out of every month.
I would just spell NDAH.
Yep.
What number? What number am I missing?
Alright. So just like I multiplied the last one by -1, this one I'm going to multiply by 4. I'm going to put a 4 outside of this x minus 2 and distribute it in. And so my new function will be 4x minus 8. This time it's called h. But this is going to be like I'm taking the original graph and I am stretching it vertically by 4. It's going to be steeper by a factor of 4. I'm going to start at -8. And I'm going to go up 4 over 1. Just keep working. You're fine. It's only 2:19. It's 6 minutes.
For me, it's 2 minutes.
Interested in winter guard? Please on Tuesday, October 29th at 6 p.m. in the band room.
Be quiet, please.
Art Club and National Art Club Society will meet on Thursday after school in room 9103. Please check Schoology for the agenda. There will be a Interact Club meeting today in room 2113 at 2:30 p.m. There will be an Avid Club meeting this Thursday, October 24th, after school, in room 2102. The greatest moment for seniors. I am proudly happy to announce this year's, and SGA as well, the 2024 homecoming course. First, we're going to start off with the gentlemen. We have Mr. Ethan Ham, Sean Herlakey, Adrian Pacheco, Will Weaver, and Clayton Williams. Please give them a round of applause and congratulate them. Now, Lily Gillette, McKenna Lee, Ava Renda, and Jada Rapetti. Final voting will begin tomorrow. Ms. Smith needs all court members to report to student services right after school today for a quick meeting. Once again, give all these lovely ladies and gentlemen a round of applause and congratulations this fall. Everyone have a great day. And as always,
Hey, listen, look.
go Tiger.
Finish this handout for homework. I'm going to collect this. I'm going to collect this tomorrow and finish it for homework.
Yes, ma'am. I'm actually about to finish this.
You should not be out of your seats, and you should not be all talking. Here's number 7. May take a picture and put it right away.
Is that the top left? Thank you.
Did you see that? Oh, you see that? She threw that.
Finish this handout for homework.